So my name is Sushant. I'm a software engineer at Google. I have completed a master degree in computer science from IIT Bombay, and I have around 7 years of experience, both in software engineering and machine learning. Dynamic programming is just a glorified form of brute forcing with caching. Once you solve enough dynamic programming problem, you will see that all the problems follow the same procedure. You just apply a brute force on the solution, and you just cache the value so that you won't have to go to that path again. So this is a definition on Wiki. Dynamic programming is a method of solving complex problem by breaking it down into collection of simpler subproblems, solving each of those subproblem just once, and storing their solution. Once you think of a problem, it usually comes down to a balance between space and time. So if you want to reduce your space, you will have to increase the time complexity. If you want to reduce the time complexity, you will have to increase your space. That's where the advanced data structure comes in. Like if you are planning to solve a range minimum or range maximum query problem without using segment tree, then the complexity is not going to come down to n square. But once you use a segmented tree, which requires actually n log n space, your time complexity also comes down to n log n. So it's a trade-off between time and complexity. Yeah, so we use DB most for optimization problems as well as combinatorial problems. So I'm going to just show some approaches, so what we can do in dynamic programming. So tabulation is one method. You can solve dynamic problem using tabulation, but for this you have to follow a bottom-up approach. So bottom-up approach, you usually use a recursive function where you are calling that function again and again till some boundary cases hits, and you can save the result of each function in some table. It could be in an array or n-dimensional array. So advantage of tabulation is fast performance with a little overhead. Oh, sorry. I was talking about memorization. I didn't see the slide. I was talking about memorization where you use top-down approach, and you use some recursive function here. So depth of the recursion and recursion stack overhead can become a concern. Yeah, these I have also seen these problems when I use a recursive function on even HackerRank or any other coding platform. It's usually good to use a tabulation method than memorization method, because memorization method you need to have a recursive function which is following the problem from top-down approach. You will be at the top, and then you will try to solve their sub problems. The advantage of the memorization is it only solves the subproblem that you need to solve. It doesn't go through all the nodes in the tree. But in the tabulation, it comes from bottom up. So you will fill the table from bottom up approach, and you don't need any recursive function for this. It can be done in a for loop, multiple nested for loops. But I usually find that memorization method is more intuitive than tabulation. So these are some tips for dynamic programming. Can you identify a recurrence relation? If you can identify a recurrence relation by just looking at the problem, it's pretty easy to calculate the complexity, time complexity, and space complexity of the problem. Or what are the base cases for recurrence? So you will have to write these cases when you are writing a recursive function. So what is your state? So state basically identifying a state means that which arguments you are going to need in the recursive function. So identifying that argument is the big part of dynamic programming problem. Once you identify that which arguments you are going to use in the recursive function, it's pretty easy from there. Yeah. So how to identify a dynamic problem? So it usually start with how many, or count the numbers of. Most likely you are dealing with a pure math problem, a complete search problem, or a dynamic programming problem. It usually also involves that minimize or maximize something. If you are trying to minimize or maximize something, it usually comes under dynamic programming problem, but it also could come under greedy algorithms. So Ashutosh has two questions.
Hi, am I audible?
Yeah.
Yeah. Okay. So my first question is, can you differentiate between the approaches of in the previous problem of modified Fibonacci?
Yeah.
Why didn't we use the recursion?
Just 1 minute, I'll show you the solution. Yeah, you can see the screen, right?
Yeah.
So here you can see, okay, yeah, because this problem doesn't need memorization. I didn't use memorization, but you should use it. I'll show you how to easily convert uh, a dynamic programming problem which complexity is exponential to linear programming, linear complexity. So see here, we usually write a recursive function first in the dynamic programming, and we don't use table in the start. But what you should do is declare a table here, whatever you can give the name. I just use dp here, and yeah, just make it a list, make it a dynamic.
You
Yeah.
are showing the optimal solution for this problem can be achieved in multiple ways, right?
What I've seen in dynamic programming is if you don't use memorization, if you don't use any data structure to store intermediate values, the solution is still going to work. Like this solution still works without using storing values, but the complexity is high because I'm not uh, caching the values. I'm not using the same values. But even the problem doesn't require that because it only taking input of 3 numbers. So you have to calculate only one time. But say that there is a test case where there are multiple inputs. So there are 100 inputs. So you are not going to run this function again and again. Once it goes to 100 or 1000, you have you have all the values calculated in the data structure, and you can just throw it out. I'll just show you how to do that. So say in a factorial problem, you are getting some input. You have to calculate a factorial of that, right? Uh, So say you are getting multiple inputs, like you are going to get 100 numbers and you have to calculate factorial for that. So you are not going to use factorial function for each of them number, and you are going to use memorization. So I'll tell you how to do that. So you got an array of integer here. Then I'm going to define a recursive function. This f is a factorial. It's going to take an value. The base condition will be, can anybody tell me the base condition? What is going to be in factorial? It's usually a 0. So factorial of 0 is 1. So that is going to be our base condition. And then we are going to return n into f of n minus 1. This is the simple factorial function. So see here, for a we are just going to print of factorial of each one. Okay. So say I give some test case input. So I'll give 3, 5, 7, and 8. Yeah. So you are getting the values now. But see what happens if I'll just write like a big number, whether will it be able to? Okay, it's able to do that. I guess they have a very high processor. But what I'm saying is you're not using any memorization. So say if this number comes first, this number comes first, and there are some numbers after that. Do you actually need to run a program for those numbers, the smaller number? Because for this number, you have already gone through. You have already calculated a factorial of 43, 65, 78, right? For 543, you have already calculated a factorial of 542. So do you actually need it to calculate it again? So instead of doing that, we can just, what we can do, I usually do this trick only. I use a recursive function. I always do bottom up approach, top down approach, and I do write a function, recursive function first, then declare a data structure. So for this, we know we are going to just need a list or array. Okay. So after this condition, what we are going to check that whether this number exists in the array or not. If n in dp dot keys. No, only in dp, I guess. It's a list, right? Let's make it a dictionary rather than. Okay, so we are just going to check whether it has been already calculated or not. If the n exists in DP, then we are just going to return it. We are not going to even make a recursive call. See, if it already exists in DP, then we can just return it. If it doesn't exist in DP, then we are going to, instead of returning it, we are going to make new value, and then we are going to return it. No attribute name keys should be keys. Yeah, so it's running. Oh, what I want to show here is, yeah, that once you calculate this value, once the program run for 543, your DP table will have 543 entries. So because it's calculating value for each, right? So even I can show you what the status of DP table here in what's happening here, how many entries it has. Print. So let's just print it here and here. See, first it has 0 entries. Once you run it for 543, it will have 543 entries. Then it will always have 543 entries unless you come up with bigger number than this. So for 43, you are not making any recursive call. It's going to run in this condition and is already exist in DP. So just return DP. This is called caching mechanism. You are caching the values of each recursive call. Does that answer your question?
Yeah.
Yeah. Okay.